Electrochemistry, second PUC chemistry na ಒಂದು important chapter. So here is the simple revision notes of this chapter. So let us understand first galvanic cell. Galvanic cell symbolic notation is important to the exam, and the symbolic notation is anode, salt bridge, cathode. So your right hand side is cathode, your left hand side is anode. At anode, oxidation takes place. So if you see the reaction, zinc loses 2 electrons and loss of electron is oxidation. Similarly, at cathode, reduction takes place. Copper ion gains 2 electrons and converts into copper. So this is the symbolic notation and reaction of galvanic cell, and in the galvanic cell, redox reaction is spontaneous, so delta G, Gibbs free energy change value, is negative. Another 3 marks important topic from this chapter is standard hydrogen electrode, and this is a primary reference electrode. If you want to calculate the electrode potential of some unknown material, you need to connect those material with this copper wire to standard hydrogen electrode. Diagram is important. In the beaker, we need to take 1 molar hydrochloric acid, and in this we have to dip a platinum foil. On this platinum foil, we need to pass hydrogen gas at 1 bar pressure. Now reaction, see, hydrogen ion present in this beaker gains 1 electron and converts into half mole of hydrogen gas. Hydrogen ion concentration is 1 molar, and symbolic notation, on platinum foil, you are passing hydrogen gas at 1 bar pressure, and in the beaker you can find hydrogen ion at 1 molar concentration in aqueous medium. And remember, standard hydrogen electrode reduction potential we need to consider as 0. Next, another important topic here is, remember the definition of inert electrodes. Inert electrodes are those electrodes which do not participate in oxidation or reduction reaction. Example, gold and platinum. And one more 3 marks important question is, materials are classified into 3 types based on the conductivity. The one who conducts are called as conductors, the one who don't conduct electricity are called as insulator, and whose conductivity is less than conductors are called as semiconductors. These are the examples important to the exam, remember. Next, if you come to the numerical section of this chapter, Nernst's equation is very important. This is a Nernst's equation, and its equation is electrode potential of the cell, nothing but EMF of the cell, is equal to standard electrode potential of the cell, E naught cell, minus 0.0591 divided by N. N is the number of electrons involving in either oxidation or reduction. Log of concentration of product ion divided by concentration of reactant ion. This is Nernst's equation. Based on this, we have 2 numericals here. The first numerical is calculate EMF of the cell, and this is the symbolic notation of the cell. At 298 Kelvin, electrode potential, standard electrode potential of zinc is minus 0.76, and standard electrode potential of copper is 0.34 volts. Now this symbolic notation we will convert into reaction. So this is anode, zinc is anode. At anode, oxidation takes place, and this side is cathode, salt bridge, right side is cathode. At cathode, reduction takes place. Now here one correction, the concentration of zinc ion is 0.2 molar, 0.2 molar. Now let us do the numerical. First, we need to find out standard electrode potential of the cell. To find out standard electrode potential of the cell, we have a formula. Standard electrode potential of the cell is equal to standard electrode potential of cathode minus standard electrode potential of anode. So here cathode is copper and anode is zinc. And one more trick is there to remember the cathode and anode. You just look at the standard electrode potential of the cell. Wherever you are getting higher value, that is cathode, and lesser value is anode. Substitute in the formula, you will get standard electrode potential of the cell 1.1 volt. Now come to the main formula. E naught of the cell is 1.1 volt, 0.095 divided by N. Log value, N value is 2 here, means zinc is losing 2 electron or copper is gaining 2 electrons. So N value is 2. Log of concentration of product. Here in the reaction, product is zinc ion and its concentration is 0.2 that we have substituted, divided by concentration of reactant. Reactant ion is copper ion and its concentration is 0.1. When you calculate, you will get log2, and log2 value is 0.3010, and when you do the calculation, you will get electrode potential as 1.091 volts. We have one more numerical here is based on this question. Calculate the EMF of the cell. This is a symbolic notation of the cell, where electrode potential of zinc is minus 2.37 volts. Electrode potential of silver is plus 0.80 volts. Magnesium ion concentration is 0.001 molar, and silver ion concentration is 0.0001 molar. Now you first find out standard electrode potential of the cell, E naught of cathode minus E naught of anode. Cathode means higher value, 0.80 substitute. Anode means lesser value, minus 2.37. You just calculate, you will get 3.17 volts. Now come to the main formula, Nernst equation formula. Standard electrode potential substitute here, then 0.09591 divided by N. N value is here is 2, because here also magnesium is losing 2 electrons, so N value is 2, log of concentration of product ion. Product ion is magnesium, its concentration you write, and concentration of silver ion, Ag plus is reactant. Here is reactant, substitute its value. As in the reaction, you can see there are two, to balance the electrons we need to take 2 silver ion, 2 Ag plus, so the concentration has to be raised to power 2. When you calculate, you will get log 10 to the power of 5, and log 10 to the power of 5 value is 5 itself. So when you calculate, you will get 3.022 volts. Now one more formula we have here is the relationship between delta G naught and E naught, and the relation is delta G naught is equal to minus N F E naught. N is number of electron, F is Faraday, and E naught is standard electrode potential of the cell. So we have an equation here for the Daniell cell. Standard electrode potential is 1.1 volt. Calculate delta G naught for this reaction, and in this reaction N value is 2, so now substitute. N value is 2, F means Faraday, and its value is 96,500, and E naught value is 1.1 volt. When you calculate, you will get this answer, and delta G naught unit is kilojoules per mole, or joules per mole, or you can convert into kilojoules per mole also. Let us move to the next topic here. We have one more formula, important formula here is calculate the equilibrium constant, relationship between standard electrode potential of the cell and equilibrium constant. The formula is standard electrode potential of the cell is equal to 0.0591 divided by N log Kc. Kc is equilibrium constant. Now we have on this equation, and standard electrode potential has been given. Now write the formula. Now substitute standard electrode potential 0.46, N value is 2, log Kc. Rearrange the formula, we'll get log Kc is equal to 2 into 0.46 divided by 0.0591. When you calculate, you will get log Kc is equal to 15.56. Again, log you send to the right side, it will become anti-log. Now while calculating anti-log, decimal point left side whatever is there you take as 10 raised to power 15, and remaining 0.56 in the anti-log table you calculate the value. Now you will get Kc value 3.63 into 10 to the power of 15. Now we have one more important formula here is conductivity and molar conductivity. We have one question, 0.1 molar formic acid solution when placed between two electrodes having area is 2.5 centimeter square, and separated by, means distance between the two electrode is 0.8 centimeter, and resistance is 6956 ohms. Calculate the conductivity and molar conductivity. Conductivity formula is conductivity K is equal to L by A. L is length, means distance between the two electrode, that is 0.8 centimeter, divided by A. A is area of cross section, that is 2.5 centimeter square. 1 divided by R. R is resistance, that is 6956. When you calculate, you will get conductivity value is 0.000046 Simon per centimeter. Now we will conduct the molar conductivity. Molar conductivity is equal to conductivity into 1000 divided by molarity. Molarity is given in the question 0.1. Conductivity just now we have calculated. Substitute, we will get 0.46 Simon centimeter square per mole. Unit also very important. Molar conductivity unit is Simon centimeter square per mole. Now one more important topic of this chapter is limiting molar conductivity. Limiting molar conductivity means conductivity of electrolyte solution at infinite dilution. Now there are two graphs based on this molar conductivity. For strong electrolyte this is the graph, and for weak electrolyte this is the graph. That is, you have to remember, very important. Next, for 2 marks, I'll ask one law, Kohlraasch law, and its application or significance. And it's this law states that limiting molar conductivity of electrolyte can be represented as sum of the individual contribution of cation and anion. Application, it is used to determine the molar conductivity of weak electrolyte, and second application, it is used to determine the degree of dissociation of weak electrolyte, alpha, degree of dissociation of weak electrolyte. Then in this chapter, Faraday's first law, very important with the formula, and Faraday's second law also very important. Along with that, you remember the products obtained at cathode and anode when you do electrolysis of molten NaCl and aqueous NaCl. These are very important for MCQs. Next, for 2 marks, they'll ask the definition of battery and the types of battery. There are two types of battery, primary battery and secondary battery. Primary battery cannot be recharged and secondary battery can be rechargeable. One of the secondary battery, lead storage battery, is important to the exam. In a lead storage battery, anode is lead, cathode is lead dioxide, and electrolyte is a 38% sulfuric acid. And lead storage battery is used in automobiles, trains, and UPS. Overall reaction is there, that is also very important. And reaction during recharge also they will ask. So these are the important points of lead storage battery. Then we have fuel cell. This is also very important, and in this cell electric energy can be generated by the combustion of fuels like hydrogen or methanol or methane. So one of the commonly asking fuel cell is hydrogen oxygen fuel cell. Diagram is important. Anode reaction, cathode reaction, and overall reaction also very important. And hydrogen oxygen fuel cell is used in Apollo's spacecraft. That is also very important. So I hope it is going to be useful for you. Thank you, students.